Assalamualaikum warahmatullahi wabarakatuh. In this video, I will proceed with the last subtopic for chapter 2, which is one-to-one function and their inverse. One-to-one function, a function f is a one-to-one function if and only if each element in the domain has exactly one image in the range. So let's say we have this graph. So this is referring to the graph of a linear. Y is equivalent to x. So let's say if we have the domain or the values of x is 1, the values of y is also equivalent to 1, meaning that one values of domain is equivalent to one values of the range. So this is an example of the one-to-one function. So the method for you to determine whether the function is a one-to-one function, algebraical method, is by using horizontal line test. So by using horizontal line test, if we have a graph, so when we draw the horizontal line along this graph, when it is intersect at most one point, meaning that this is a one-to-one function. When we draw a horizontal line along this graph, so it is intersect more than one point, meaning that it is not a one-to-one function. Now let's look at to the inverse function. So on the inverse function, the domain and the range we have here, domain for the function of f is equivalent to the range of f inverse, and the range of the f is equivalent to the domain of the f inverse. So this is the theorem on the inverse function. When we have composite gf, when it is equivalent to f composite g, and these two composite is equals to x, meaning that f is the inverse of the function g, or g is the inverse of the function f. Or in other words, f inverse, f composite of the f inverse, when it is equivalent to the f inverse composite with the f, when it is equivalent to the x, so it is inverse to each other. Now let's look at to this example. Show that f and g are inverse to each other by using the previous theorem. So how can we prove here? First, we need to find out the g composite f or f composite g. So let us try to find out f composite g first. So f composite g is equivalent to the f. So g is x plus 1 over 3. And then our f is 3. Substitute x with the x plus 1 over 3 minus 1. This one we can cancel out. So what left is just x. And then when we try to get g composite of f, so f is 3x minus 1, and g is 3x minus 1 plus 1 over 3. So we will get also equivalent to the x. So since our f composite g is equivalent to the g of the composite of f, and this values is equivalent to the x, therefore it is proven that f and g are inverse to each other. So you can prove also for the question in the part B. So when that composite is equals to the x, meaning that they are inverse to each other. Now let's look at the how to graph the inverse function. The graph or the function can be the function has an inverse if it is a one-to-one function. For example, in this graph, so when we draw a horizontal line along this graph, so let's say this is horizontal line along this graph, so this shows this line intersect only one point, meaning that this graph is referred to a one-to-one function. When the function is one-to-one, the function will have an inverse. So the graph of this function f shows the point AB on the graph of f. So when this graph has an inverse, so we can sketch the inverse graph. So when this is the original graph, so what is the properties of the inverse function? So the graph of the f inverse is a reflection of the graph of f about the line y is equivalent to x. So this is the most important point. So how can we sketch the graph of the f inverse? We have to put the line for the y is equivalent to the x. Then we have to reflect the graph of the function f on that line. So you will get this graph So this graph is referred to the graph of the function f inverse. Okay, so let's look at today's example. So we have the function f is equivalent to square root of x plus 2. So what we have to do here is, first we need to find out the inverse function. So given fx is square root of x plus 2, so let us let y is equivalent to the fx. So y is equivalent to the square root of x plus 2. So we have to put x as a subject. So y squared is equivalent to the x plus 2. Therefore, x is equivalent to y squared minus 2. So this is our inverse function. Therefore, f inverse x is equivalent to the x squared minus 2. So by right, if you try to sketch the graph of the x squared minus 2, so from the basic graph x squared, so it shows that negative 2 shows that your graph will moving down 2 unit. So it should be something like this. So this is referred to the graph of x squared minus 2. So this is the values of, this values is, coordinate is 0, negative 2. So when we try to sketch a horizontal line along this graph, it is not one-to-one because it is intersect more than one point here. So since it is not one-to-one, but the question asks to sketch the graph of the f inverse, meaning that this quadratic function must have the restriction domain. So how can we identify the domain? So let us try to sketch the original function. So the original function, when we try to sketch, it is equivalent to the graph of the square root, and that plus 2 shows that the graph will move to the left 2 unit. So this is how the graph looks like. So we will have something like this. So we will have this first graph, or this is referred to the function f. And we know that the properties of the function of f and its inverse, it will reflect on the line y is equivalent to the x. So when you try to reflect this graph, so it will be something like this. So the coordinate of, so the original coordinate here is, we have here negative 2, 0. So this one also negative 2, 0. So on the graph of the f inverse, the coordinate now will become 0, negative 2. X will become y, y will become x. And then you have to make sure this graph is symmetry. So this one is symmetry. And finally, this is the graph of f and f inverse on the same axis. Okay, so now when we try to go back to this function f inverse, so just now I have mentioned that for the x squared minus 2, this is how the graph looks like. So since when we draw the horizontal line along this graph, it shows that this graph is not a one-to-one, or if it is not one-to-one, there is no inverse. But since when we try to sketch the graph reflection on the function of f, this is the graph that we get. Therefore, actually this part does not appear. So for the function x squared minus 2, there is a restriction domain. So we just show on the values of x is greater than equivalent to 0. So for any function of quadratic, for the quadratic function to have an inverse, there must be a restriction domain. Otherwise, the function or the graph of the quadratic does not has an inverse because it is not one-to-one function. So this is the graph of the f and f inverse on the same axis together with the line y is equivalent to the x. Now let us try to determine the domain and range for the graph of for the function of f and f inverse. So domain for the function of f, so you can just looking at to the graph, or you can just look at to the function of f. So let's say if we focus on the graph, so the first values of x is negative 2. For the domain of the function of f is close negative 2 until infinity. And how about the range of the function of f? So the range of the function of f, so it will start from the values of y 0 until infinity. Therefore, it should be close bracket 0 until infinity. And when you try to determine the domain and range for the F inverse, so this is our graph of F inverse. The domain of the function F inverse is equivalent to this is the coordinate of 0, negative 2. So therefore, our domain starting from x values is 0 until infinity. And then how about the range? So the range is starting from the y values will start from the values of negative 2. So it should be negative 2 until infinity. So as you can see, domain of the function f will become the range of the f inverse, and the range of the function f will become the domain of the f inverse. So that's why the coordinate of negative 2, 0 on the graph of the f inverse will become 0, negative 2. So domain will become range of f inverse, range will become domain of the f inverse. Okay, please try out exercise 1 as well as exercise 2. Thank you.